Dear students, I welcome you all for the case study discussion on selection of antennas for mobile base stations in urban areas. So far we have seen many type of antennas and its fundamental parameters. We have studied the directivity, beam width, bandwidth, front to back ratio, radiation intensity of antennas, radiation pattern, etc. By using these all parameters, how to select a particular antenna for mobile base station is a case study topic we have taken today. Let us discuss.
Okay, here the rapid growth of mobile communication have created a strong demand in wireless network that can support high data rate and large number of users and reliable communication. In cities, factors such as tall buildings and dense population and network traffic can make the signal coverage and the quality challenging. So to handle these conditions, the mobile communication must be carefully designed with a more efficient and performance component. And antennas plays a very important role in mobile base station. Here it directly control the signals that are transmitted and received. So we have to design an efficient mobile communication system to have a reliable and stable communication.
So what are the challenges in urban communication?
So urban communications challenges are diffraction, refractions, isotropic and gains in directivity and pattern. So that and all the challenges of urban communications. So the user friendly as connected with the capacity and network is both are related to the mobile communications that install the antennas. So it will reduce the mobile communications of 4G and 5G. So it will gain the directivities of the maintenance of the preventer. So it both are related into the like antennas and permittivities of the free space. It related to the relationships between the antennas, and it controls the maintenance and it prevents the maintenance of the controllers.
So what are the parameters can be considered?
So I would like to explain about the parameters. Basically in electronics, not only for antenna, whenever we design a circuit, we are fetching for any device, we will check about the parameters of that device by checking its dataset. Likewise, antenna has certain parameters like radiation intensity and front to back the front to back ratio and beam width, bandwidth, etc. And so first let me talk about radiation pattern. Radiation pattern, it is the representation of graphical representation which tells how the radiation power has been radiated. And secondly, I would like to talk about radiation intensity. First of all, intensity means how deeper the power energy has been radiated. So here in antennas, the intensity of the radiated power will be calculated using this radiation intensity. And front to back ratio. That is how the front side of the radiated power versus the back side of the radiated power. In unidirectional, it will be only on the front side, and in bidirectional, it will be from the both the sides of the antennas. And beam width. Beam width is the angular Angular width. Beam is the angular width of the radiation power, and these are the following parameters. And I would like to talk about isotropic antenna, which is the hierarchical antenna. It is used for theoretical purpose, not for practical purpose. And this antenna will be spreading the radiation in the in all direction equally. This is the main key point of that isotropic antenna.
So talk about directional sector antenna. Directional sector antenna send the signal in a particular direction. So that usually in the sector antennas 60 or 120 degree sending the data. The sector antennas mainly focused on stronger signal strength, so high gain. So it will be control the beam width, like Sanketa said, and it will be reduce the high front to back ratio. So the sector antenna mainly are more used on the cell phone towers, like urban areas, okay, cities. So next we move to radiation pattern and coverage comparison. So already Sangeeta said isotropic antenna, like imaginary antenna, and it will be sending signal in all area, all directions, and it look like the coverage area look like a sphere. So and then it will be coverage in all direction and same signal strength. So next and I'm previous talk about the sector antenna. Sector antenna, it's only directional antenna, and then it coverage particular range or direction. So it will be main focused on the strength based. So that.
Next.
We'll be explaining the urban polarization. Like base urban polarization stations, they place vertically or 45 degrees slant employment. So the reception of the signal is increased and the mismatch placement loss, which is gradually reduced. Coming to the industrial employment, it uses an 120 degree advanced system configuration. It's a tri-sector configuration in which the MIMO antennas are employed. It increases the capacity and the spectral efficiency, which results in continuous good strength of signal and smooth user experience.
I will explain about the advantages of this problem statement. Sector antennas are used in urban areas because they give more power to signals. These signals are only sent in only one direction. These are used to reduce unwanted noise, and it gives power efficiency, frequency to the signals.
So thank you, dear students. You have well discussed about how to select antennas for mobile stations in urban areas. And because of increasing demand of mobile communication, high capacity, high reliable signal need, and this you have well applied all the antenna basic concepts and how to select an antenna for this case. Thank you so much for your contribution.
Thank you.